Hi everybody, this is section 6.4 for finite math, and I can hear you guys getting excited because this will be the last lecture that you're going to have to listen to. So best wishes for all of that. Okay, this is going to be a hodgepodge of a lot of little things, and there's going to be some things that I will not talk about. If I don't talk about them, I guess what I'm saying is you won't be responsible for them. Okay, so I'm going to start off with this one here. Okay, this is going to be conditional probability. Student drivers at University Heights High School. So I've got grade 9, 10, 11, and 12. And if you go across, this column says they have no license. So for the very top one here, for the freshmen, 117 people do not have their license, which really, I guess you would expect that. License with no recs, license with at least one rec, and then my total. And I did the same thing for sophomores, juniors, seniors, and then of course you got your totals along the bottom. Okay, now remember, I'm going to use this here. Probability, remember how I talked about it's good out of total. Okay, so if one student is selected at random, what's the probability? So you got 749 students. What's the probability the student is a sophomore? So you say, good to be a sophomore. How many sophomores are there? 197. Out of a total of 749. Okay. The second one says, what's the probability the student has at least one rec? Okay, at least one rec, we're going to use this column here, and on the bottom I see 340 people have had a rec. 340 out of 749. Number 3, the student has no license given, there's a key word there for you, given the student is a sophomore. So at this point, we know he's a sophomore, so that means, let me get my other pen here. That means since we are given that it's a sophomore, we're only talking about sophomore people. My total now becomes 197. I'm not talking about everybody. I'm just talking about the sophomores. Now, out of the 197, I want to know what's the probability they have no license. That would be that number there, that's 65. So 65 out of the 197 sophomores do not have a license. So when you see the word given, that means it is conditional. I'm giving you a condition. In this case, we're only talking about sophomores. So I'm only looking at that one line. That changes the bottom number. Let's go to this one. What's the probability the student is a junior? There's that word again, given he is licensed and has had no recs. So what are we given? We're given this column right here. Since I'm given he has no recs, my bottom number now becomes 160. I'm given he's licensed with no recs, therefore I'm only talking about 160 people. Now, out of those 160, how many of them are juniors? Looks like 55. So that answer is 55 out of 160. Now, I know we can put that in lowest terms, but we're not going to waste our time for that one. Number 5 says, what's the probability the student is a senior and has no license? Okay, now let me point something out here. We're going to look for the word given. Is the word given in this problem? No. Therefore, my bottom number is 749 because it's not conditional. The student is a senior and has no license. 30. There's 30 people. That's an and, so it's the intersection. It's the intersection of this row and that column. That gives you the 30. There's your top number. And it's out of the 749 because it's everybody. And then the bottom one, now this is going to be a little bit tougher. The student is a freshman or has a license with no recs. So if they're a freshman, that means this one, and this one all work. License with no recs, those three work also. So you're going to take 117 plus 27 plus 1, that takes care of the top three, plus 51 plus 55 plus 27. Okay, get my calculator ready. I got 278. So my answer, the probability, is 278 over that total of 749. Again, it's 749 because it doesn't have the word given. Okay, so that's your intro to what conditional probability is. If you have the word given, that changes your numbers. Okay. Intro, part 2. Okay, so let's say that we are tossing a pair of dice. If you remember, I said in the other lecture for 6-2, I said anytime you see where we've got two dice, go ahead and put this in where it shows your sums. Okay, so what's the probability of getting a 6? I have, and that means a sum of 6. I guess maybe no, that's not what I meant. Okay. Yeah, it was sum of 6. So when I look at a sum of 6, I got 1, 2, 3, 4. There's 5 out of the 36. That's a sum of 6. Now, the next one says you have at least 1, 2. Well, that's got a 2. That's got a 2, that's got a 2, that's got a 2, that's got a 2, that's got a 2. When I say it's got a 2, you took 2 plus 6 to get 8, so you used a 2. So that means you got 1, 2, 3, 4, 5. There's 6 of them. There's also 6 of them going this direction. But if you counted them up, 6 here, 6 here, you would say, well, that means there's 12. But remember, this one right here, you'd be double counting that one. So 6 plus 6 minus 1, it gives you 11. The answer to this one's going to be 11 over 36. C says, what's the probability of getting a sum of 6 and at least 1, 2? So the sum of 6 would be right here. And it says we have to use a 2 to get it. Well, this guy right here, that's 6. We got a sum of 6 and we use a 2 to get it. And then I've got another one right here. There's a sum of 6, I use that one. That's going to be 2 out of the 36. That one I can put in lowest terms, that's not a problem. 1 over 18. Now, D says, what's the probability of getting a sum of 6 or? I did and. Now, if it's or, that means any one of these guys would work. And any one of these, I'm going to put dots in all of these. Some of them already have a dot. Any place where there's a dot, then it works. If you count them up, I'm going to go the first row. I got 1, 2. Second row, 3, 4, 5, 6, 7, 8. Third row, 9, 10. Fourth row, 11. Fifth row, 12, 13. And the last row, 14. Looks like that's going to be 14 out of 36. That's 7 over 18 if you wanted to do that. Okay, the next one says given. So it's conditional probability. So what's the probability of getting a sum of 6 given we got a 2? So if we got a 2, I'm going to put these in a circle. All of these had a 2. All of those had a 2. So at this point, we know that the bottom number is going to be 11. Count everything in the circles. Going across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's the same thing I got up here with that 11. Now, what's the probability of getting a sum of 6? So out of all these ones circled, I've got a 6 here and a 6 here. That's 2 of them. That answer is going to be 2 out of the 11. So when it says I was given a sum, given a 2, oh, I didn't read that right. This says I got a 2 on the first roll. Okay, so here's a 2 on the first roll, so there's 6 of those. I didn't read the problem right. That's 6. Now, out of those, how many of them gave you a sum of 6? 1. So it's going to be 1 over 6. And F, what's the probability of having at least one die showing a 2, given you got a sum of 6? So I got a sum of 6 here, 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 and here. So given a sum of 6, that means the bottom number is going to be 5. Always start with the second part of that. Now, out of those 5, what's the probability of having at least one die show a 2? We had 1 there, because I had a 2 up here, and 1 there. The answer is 2 out of 5. That's conditional probability. Okay, let's look at this one. Suppose a certain mathematics class contains 26 students. Of these, 14 are econ majors, 15 are first-year students, 7 are neither. Suppose that a person is selected at random from the class. What is the probability that a person selected was both an econ major and a first-year major? Okay, now, you already saw it because I put my hand over the top of it, but this information here, you can put in a Venn diagram. Okay? Now, this says 7 or neither, so that means I put the 7 out here first. That takes care of that one. Okay, then 14 are econ majors, so altogether is 14. Problem is you don't know any of those numbers. You can calculate it if you work it backwards because there were 26 altogether, so that means there's 19. I got to figure out the numbers I can add together to get 19. It works out 4, 10, and 5. Now, once you have that, what's the probability that a person selected is both an econ major and a first-year student? That would be this. So that's 10 out of a total of 26. We'll put that in lowest terms, say 5 over 13. In B, it says, suppose we are given the additional information that the person selected is a first-year student. We're given it's a first-year student. That means this is all I'm looking at. The 10 here and the 5 here. What's the probability they're an econ major? Well, 10 of these 15 are econ majors. So that's going to be 10 over 15, which is 2/3. When it said given, we are given something. That means, in this case here, we're only talking about those 15 people. We don't care about the rest of them. Now, if we're given that, what's the probability that they're going to be an econ major? These guys here are econ majors, so that gives you the top number, 10 out of the 15. Okay, again, conditional probability. Okay, here's the next one. There's a formula they give you in the book, but sometimes sometimes it's easier if you think logically, and I tend to do that, but I'll come back to the formula. So if we take a card from a standard deck of 52 playing cards, what's the probability it's a king? You know there's 4 kings out of 52. Lowest terms, that's 1 over 13. B says, what's the probability of drawing a club? There's 13 out of 52 cards. It's 1/4 in lowest terms. What's the probability of drawing a king and a club? Well, that would be the king of clubs, so that's 1 out of 52. And if I said drawing a king or a queen, Okay, so if you'll remember, we had, I'm going to come up here, back in chapter 5, the number in A or B is equal to the number in A plus the number in B minus the number in both A and B. Okay, so A or B, the number in this case here, there was 4 kings, there was 13 clubs, there was 1 that was both, so 4 plus 13 is 17 minus 1 is 16. The answer down here is going to be 16 over 52, or in lowest terms, that's 4 over 13. Conditional probability. Now we draw 2 cards with no replacement. What is the probability of drawing a king given we know it's a club? Think of it this way. If I know it's a club, how many clubs are there? 13. What's probably drawing a king out of all that? How many kings are there in the clubs? 1. Now, you could go back to this formula if you wanted to. If I plug those in, the F would be the club, so the probability of getting a club, there's 13 clubs out of 52. The probability of E intersect, there's 1 out of 52. The 52s drop out and you get 1 over 13. It's probably easier to do it this way. That's why I said sometimes you want to just do things logically. What's the probability of drawing a club given we know it's a king? So if it's a king, how many kings are there? 4. The kings give you the 4. Now out of those 4 kings, how many of them are a club? 1. You're thinking logically now. Okay. Example 2. 20% of the employees of Acme Steel Company are college graduates. Of all the employees, 25% earn more than $50,000, and 15% are college graduates earning more than $50,000. What is the probability that an employee selected at random earns more than 50 per year? Okay. Now, I would probably do this, okay? It says 20% of all those people are college graduates. So probability of a college graduate is 20%. Of all employees, 25% or earn more. So this would be, what do we say? Probability, let's see. Boom, 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 boom. Let's do this. Let's make up a number. I'm trying to make this easy for you. Let's just say that the total number of employees, let's say that's equal to 100. So 20% times 100 ends up being 20. Okay. So number of college grads equals 20. Okay. of all the employees, so 25% earn more than 50% or 50,000. So number greater than 50K, it's 20, did I say it right? Yeah, 25%, that's 0.25 times the 100, that's going to be 25. %are college grads, so if I take 15%, 15% would be 15. I picked 100 so I get easy numbers here. Okay, so this is 25% of, so it's 25% of the college grads. College grads was 20, so I multiply that by 20, and that should be 5. I'm getting my numbers mixed up here. What's the probability that an employee selected at RAM earns more than 50,000 given they are college graduates? So the number of college graduates was 20, so 20 goes on the bottom. Can't write. Okay, what's the probability the employee selected at random earns more than 50? So if they earn more than 50, that's going to be 5. 5 over 20 is 1/4. 5 was the number making the college graduates more than 50,000. So that's why I use this one. I didn't have to use the 25. Okay, I probably screwed that up more than anything else. Hopefully I do better in the class. Okay, more good stuff. Here's some more formulas for you. Assume that a certain school contains an equal number of female and male students and 5% of the male population is colorblind. So that would mean 95% of the males are not colorblind. Find the probability that a randomly selected student is colorblind. I'm missing some information there. I didn't put the whole problem. I can't do that one. I need to tell you how many are male and how many are female. Example 4, cards. A sequence of 2 playing cards is drawn at random without replacement from a deck of 52 playing cards. What's the probability the first card drawn is red and the second card is black? Okay, so 2 things are happening here. We want to get a red one first and a black one second. The probability of getting red on the first card, there's 26 red cards out of the 52 to choose from. When you go to the second one, because it says without replacement, that means I take that red card and I put it off to the side. There's now only 51 cards left. How many of them are black? All 26 are still in there. So if I take 26 times 26, that number on top is 676. And 52 times 51 is 2652. Now, if I would have been smarter, I would have looked at it and said, okay, 26 goes here once and down here twice. Okay, that 2 goes up here 13 times. And, okay, so 13 times 1 is 13 and 51 on the bottom. If I put that in lowest terms, I should get the same number. Okay. Now this one, I've got things typed in there in blue. I don't know if you can see them well enough, but let me talk through it. Okay, determining whether probabilities are independent. I'll tell you what, I'm going to skip that because that's not going to be on the test. I don't want to bore you. So we'll forget that one. So if it says independent, you do not have to worry about that. Same thing on that page. Oh, I guess that's it. So there's a lot there you're not going to have to worry about. Okay, that's all I got. It takes care of 6.4. I was rushing through. I probably didn't do a very good job. I apologize that. Anyway, that takes care of all the lecture stuff that you're going to need to know. And I'll stop there and I will see you in class.